The question is, in an examination, a student can choose the order in which two questions, in bracket, question A and question B must be attempted. If the first question is answered wrong, comma, the student gets 0 marks. If the first question is answered correctly and the second question is not answered correctly, comma, the student gets the marks only for the first question. If both the questions are answered correctly, comma, the student gets the sum of the marks of the two questions. The following table shows the probability of correctly answering the question and the marks of the question respectively. Question, probability of answering correctly, marks, table given. Question A, probability 0.8, marks 10. Question B, probability 0.5, marks 20. Assuming that the student always wants to maximize their expected marks in the examination, comma, in which order should she attempt the questions and what is the expected marks for the order? Assume that the questions are independent. A, B, C, D, four statements given. A, first question B and then question A expected marks 22, like that B, C, D given. This question is from engineering mathematics from the topic probability and statistics, subtopic random variables, average. The solution is, so take care the table. So question A, he can attempt first, then question B, or question B first, then question A. So there are two cases to find expected marks, maximize we are considering, and in which order they will get the maximum expected marks. So let us denote the random variable x with the total marks and p of x is the probability. So what is the total marks means? If the first question is wrong, whether by A first or B first, that means let us take both are wrong, then the total marks 0. If A correct, that is A is attempting correct first and B is attempting wrong, so then the total marks for that case is 10. Now if the question B first, then question A, B correct, A wrong, then the total marks is 20. If both are correct in any order, that is question A first, question B second. Similarly, question B first, then question A second, but both are correct, then the total marks is 30 marks. So I'm going to do the next slide. Solution. Let x, capital X, be a random variable denote total marks and p of x is the probability of those marks. Then this is the table, capital X is equal to small x, p of x 0, 10, 20, 30. So for getting 0 means A, B, wrong. That is the meaning. For getting 10 means correct, B wrong. For getting 20 means B is attempting first, correct, A is next, wrong. So here both are correct. In whatever order, both correct. 10 plus 20, 30. So getting 0. So whatever it may be, A wrong, B wrong, A is attempting correct answer is 0.8. So attempting wrong answer 0.2. B is given in the previous slide. See, B is given answering correct 0.5. So the question B, she attempted answering wrongly is also 0.5. Okay, 0.2 into 0.5. This is which is giving 0.1 for this 10. Question A correct, question B wrong. Question A correct is 0.8 and question B wrong 0.5. This simplifies to 0.4. Refer the question. 20 marks means B correct first, then A wrong. So B correct means 0.5. A wrong means 0.2. Simplifies to 0.1. So here A correct, both are correct. Let us take A first, B second. Or whatever, B first, A second, whatever it may be. So A correct, answering that is 0.8. B is also correct, that is question B also correct, answering 0.5. So which is simplified to 0.4. So from this, sum of all the probabilities, this is a discrete random variable x is a summation taken over all x values. P of x is equal to 0.1 plus 0.4 plus 0.1 plus 0.4 is equal to. So here this x is discrete random variable. RV means random variables. Okay. Now two cases. Case 1. First question A, then question B. Okay. This is the case we are considering. So they are asking, do you remember the question? Expected marks. Okay. Expected marks. That is expectation means average. Yeah. Implies expected marks is nothing but E of x. Because discrete random variable operator is summation taken over all x values. This x into P of x. X value 0 into 0.1 probability. Next 10 into. So first question A, then question B. So 0 and 10 marks we should consider into its probability 0.4 and maybe both are correct in this. That is 30 into 0. So this simplifies to 4 plus 12, 60. Now case. So whenever first question A attempting, then the favorable cases for marks 0, 10, 30. Case. First question B. Then question A. So in this case, expected marks is E of x is equal to summation taken over all x values P of x. Again, for favorable cases, first question B, then question A is 0, 20, 30. So 0 into 0.1 plus 20 marks into 0.1 plus 30 marks into 0.4. This simplifies to 2 plus 12 is equal to 14. So case 1 16 marks, case 2 14 marks. So therefore, case 1 giving maximum expected marks. So question 1 first, that means question A first, question B second, expected marks is 16. Please remember options. So option A ruled out, option B ruled out. First question A, then question B. Okay, that is answer is 16. So please check. First question A, then question B, expected marks is 6. So accordingly, the option is B. Therefore, option is B. So answer is accordingly option B. That means question A first attempted correct, question B attempted wrong. That is here 30 is correct. The into mark is wrong. Take care. This is very, very important and tough question also. So this is end of the question. The question is, suppose that f r to r is a continuous function on the interval, closed interval minus 3 comma 3, and a differentiable function in the interval, open interval minus 3 comma 3, such that for every x in the interval, comma, f dash x less than or equal to 2. If f of minus 3 is equal to 7, then f of 3 is at most. This question is from engineering mathematics, from the topic calculus, subtopic mean value theorem. Solution is, so here that is the condition function f of x is continuous in closed interval a comma b, differentiable in open interval a comma b. These are the two common conditions in mean value theorems. And first derivative less than or equal to 3, function value at minus 3 is equal to 7. Usually closed interval a comma b is here minus 3 comma plus 3. So solution is by Lagrange's, because we don't know fx value, we cannot say f of a is equal to f of b or not. But the two conditions of Lagrange's mean value theorem here satisfied, that is continuous in closed interval AB and differentiable in open interval AB. So that's why I'm using Lagrange's mean value theorem instead of Rolle's mean value theorem. Lagrange's mean value theorem comma f dash x equal to f of b minus f of a whole divided by 3 minus of 3 b minus a, where this x is a point or belongs to open interval minus 3 comma 3. So f of 3 is how much? It is not given. We are going to find f of minus 3 is 7 given. So f of 3 minus 7, 3 minus of minus 3 simplifies to 6. Since f dash x less than or equal to 2, therefore f of 3, this is equation 1. So f dash x value here substitute f of 3 minus 7 divided by 6 less than or equal to 2. 6 into 2, 12, 12 plus 7, 19. So f of 3 less than or equal to 19. That means f of 3 value 19 or 18 or less than 19 means 18.1 or 17, etc. So at most means maximum, that is 19. Therefore, f of 3 is at most 19. So the answer is 19. This is the end of the question. The question is, for two n-dimensional real vectors p and q, comma, the operation s of p comma q is defined as follows. S of p comma q is equal to summation I is equal to 1 to n p of I dot q of I. Let L be a set of 10-dimensional non-zero real vectors such that for every pair of distinct vectors p comma q belongs to L, comma s of p comma q is equal to 0. What is the maximum cardinality possible for the set L? Four options A, B, C, D given. This question is from engineering mathematics, from the topic linear algebra basics, GATE 2021. The solution is so here S of p comma q is given as sum of the products of the corresponding vector, that is dot product of two vectors S of p comma q. The solution clearly S of p comma q is equal to summation I is equal to 1 to n p bracket I dot q bracket I is the dot product of two vectors p and q. Given L is a set of 10-dimensional, here spelling mistake, dimensional, here cardinality. L is a set of 10-dimensional. 10-dimensional means that every vector containing 10 components. For example, 2-dimensional vectors, 1 comma 2, that is coordinate geometry 2D representation, x comma y, 3D representation x, y, z. Here 10-dimensional vectors. 10-dimensional non-zero, that is each vector is non-zero vector. Real vector means all the components, all the elements of 10-dimensional vector, each 10-dimensional vector are real numbers. Real vectors such that small st means such that every pair of distinct vectors p comma q belongs to L, comma s of p comma q is equal to 0. So that means dot product is 0. Implies p and q are orthogonal vectors. Implies p comma q are linearly independent vectors. So set of orthogonal vectors are always linearly independent. Please remember, this is a property from the basics matrices vector algebra, linear algebra chapter. A set of orthogonal vectors, non-zero vectors, is always linearly independent. So that means implies whenever you are going to take two distinct vectors in the set L, which is containing 10-dimensional vectors, the dot product is 0. Okay. So, and we remember an n-dimensional vectors, set of n-dimensional vectors set of all n-dimensional vectors never contain more than n linearly independent vectors. That is very, very important property from vector algebra. That means vector spaces, linear algebra topic. So here real is real. That means L is the set of non-zero orthogonal vectors. Vectors are distinct. So every pair of distinct vectors. That means already L is a set. A set never containing a repeated element. So automatically L is the set of non-zero orthogonal vectors. So that means the vectors in L are linearly independent. Li stands for linearly independent. We know that an n-dimensional means all vectors never contain more than n linearly independent vectors. So here L is a set of 10-dimensional non-zero real vectors given. That means that it doesn't mean that L containing only 10 vectors. It is containing so many vectors, but each vector is a 10-dimensional. And we proved all these. That means L is a set of non-zero orthogonal vectors if the vectors are distinct. That means the vectors in L are linearly independent if vectors are distinct. Distinct means different. And this is a vector space property from linear algebra. We know that an n-dimensional set of all vectors never containing more than n linearly independent vectors. That is implies cardinality. That is cardinality means the number of elements in a set. Cardinality L is less than or equal to 10. Hence, maximum is 10. Maximum cardinality possible for L is 10. So the answer is 10. Accordingly, the option is D. This is the end of the question. The question is, suppose that P is a 4 cross 5 real matrix. The matrix P is a 4 cross 5 matrix such that every solution of the equation Px is equal to 0 is a scalar multiple of rho transpose matrix, that is 2, 5, 4, 3, 1 transpose. The rank of P is This question is from engineering mathematics from the topic linear algebra, subtopic solutions, that is homogeneous, non-homogeneous equations, and then linearly independent solutions, etc. Solution P is 4 cross 5 matrix. Okay, MAT means matrix. Px is equal to 0 is homogeneous system for which every solution that is x, capital X, is a scalar multiple of 2, 5, 4, 3, 1 row matrix transpose. So this is non-zero solution. Okay. So therefore X is non-zero, and we know that non-zero solutions are infinite. Non-zero solutions are infinitely many, and the relation between all the solution looks like a scalar multiple of column vector 2, 5, 4, 3, 1 because it is given in the question. Since every solution is a scalar multiple of column vector 2, 5, 4, 3, 1 implies every solution is of the form lambda into 2, 5, 4, 3, 1. This lambda is scalar. So when two solutions are two vectors linearly dependent, one is a scalar multiple of other. So here every solution is a scalar multiple, means the number of linearly dependent solutions. Therefore, the number of linearly independent solutions of the homogeneous system Px is equal to 0 is 1. We have a ready-made formula for finding number of linear independent solutions is n minus r is equal to 1, where n is number of variables, r is rank of the matrix, coefficient matrix, rank. So n is number of variables. So how it is number of variables? P is multiplying with x. So P is a 4 cross 5 matrix, that is 4 rows, 5 columns. Each row containing 5 elements, which is multiplied by x. So x is a, and x is of order compulsory 5 cross, because each row of a matrix P having 5 elements. So it must having 5 elements in a column. Solution is a column vector. Okay, so that is 5 cross 1. So that means solution containing number of variables also. That means n is equal to 5 minus r is equal to 1 implies r is equal to 5 minus 1, 4. So is the rank of P. Okay, so here x is a contains number of unknowns. Five cross one matrix is 5 unknowns automatically. So the answer is 4. This is end of the question. The question is, for a given biased coin, the probability that the outcome of a toss is a head is 0.4. This coin is tossed 1000 times. Let x denote the random variable whose value is the number of times that head appeared in these 1000 tosses. The standard deviation of x rounded to 2 decimal places is. This question is from engineering mathematics, from the topic probability and statistics, subtopic distributions, random variables. So here bias. So probability of outcome is head is given 0.4. So automatically probability that outcome is tail is 1 minus 0.4, that is 0.6. It is tossed 1000 times. This is n is equal to 1000 times. Now x denote random variable number of times that head appears in this 1000 tosses. They are asking standard deviation of x. Now solution, let small p is equal to probability of outcome of a toss is head is given 0.4. Q is nothing but probability of outcome is tail. Is nothing but 1 minus p is equal to 0.6, and n is equal to 1000, number of independent trials 1000 tosses. Okay, so x is already random variable given. So here p is not small, but here n very large. If n is very large, p is very small, then only apply Poisson distribution, otherwise binomial distribution. So clearly x follows binomial distribution. Okay, so that is x denote the random variable number of times that it appeared in these 1000 tosses already given. So we know that standard deviation. So this is a random variable. Denote number of times that had appeared in these 1000 tosses. Standard deviation of binomial distribution, that is BD is the full form binomial distribution, is square root of n into p into q, which is nothing but square root of 1000 into 0.4 into 0.6. So this equal to 240 under root. That is square root of 240. Approximately they are asking up to 2 decimal places. So 15.49 decimal places. So the answer is 15.49. This is the end of the question.